Welcome to this session, which is part of the Ethical Battles in Science and Medicine debate strand, and this is the Trust Me, I'm a Scientist session. We're sponsored today by the Wellcome Trust. Right, so today's session is about whether we should trust science, and also to what extent, to what end. As science has advanced and improved the quality and duration of our lives, so has grown the expectation for science to have a social impact. And with this demand for social impact comes some issues with science, perhaps overstepping the mark or overstepping boundaries. A recent example of this is from Associate Fellow of the British Psychological Society, Dr. Eric Sigman, who believes that the youngest children whose brains are undergoing massive development should not watch any television at all. So you may have heard about this recently in the news. He says that it's linked to problems ranging from obesity and heart disease to poor grades and a lack of empathy. He will tell an EU parliamentary working group on the quality of childhood that television and computers should be kept out of the bedroom until a child is 15. Dr. Sigman's work and studies by other researchers link the television and computer time with problems including obesity, high cholesterol, high blood pressure, inattentiveness, decline in maths, reading, sleep disorders, and autism. These are kinds of examples lead to these questions that we're going to be discussing and potentially debating today about how we evaluate good and bad science and research, and whether scientists are, in effect, bullying people and basically bullying people to do things according to the research, or if politicians and the government are sort of bullying scientists to do research that impacts our lives. So we're going to take a look at these questions today and ask, what role do we want science to play in informing and changing how we live our lives? So without any further delay, I'm going to introduce our panel today in the order in which they're going to speak. So our first speaker is Imran Khan. He is the director of Campaign for Science and Engineering, which is an organization that fights for investment in research, better science advice, better science education, and more rigorous science advice in government. And he's also been named one of the 10 most influential figures in UK science under the age of 40. So we're really pleased to have you. There's
not much competition for that one.
Next, our second speaker is going to be Dr. Roger Giner-Sorolla, who's a reader in social psychology at the University of Kent. He is the author of a recently acclaimed book, Judging Passions, Moral Emotions in Persons and Groups, and he's published extensively in top psychology journals. And then third, we'll have Professor Sir Mark Walport, who is the director of the Wellcome Trust, our sponsor for today's session and this strand as a whole. He also will become the government's chief scientific advisor in April next year. He has a very extensive, impressive background and too many achievements to mention at the moment, but he is a member of numerous international advisory boards and is a fellow of the Royal Society. So thank you, Mark, for joining us today. Finally, we're going to have Dr. Stuart Derbyshire, who is co-producer of this session, speak, and he is a reader in psychology at the University of Birmingham who researches and writes about pain, experience, consciousness, and neuroimaging. He publishes extensively in top journals such as the British Medical Journal, and his research informs policymakers who are interested in the debate surrounding fetal pain in terms of abortion and abortion legislation.
So I think the problem that I've been invited to debate is that scientific facts can be portrayed in society as received authority, and that as a result, society becomes increasingly enthralled to science and perhaps less free as a result. And if that happens, it is concerning. It's dangerous when people live their lives subject to forces they can't understand and can't engage with. So we need to change it if it's happening. But I think to change it, the solution isn't to have less science in public life and public debate, but actually have more of the public in scientific life and in scientific debate. If we succeed, we'll be able to get the public to engage with and discuss science more and question it more as well. And I also think that the very nature of science means that there's a good chance we should be able to do that. The received authority, as problematic as that word is of scientific facts, is still very different to the received authority of, say, religion or of governments. With those areas, questioning facts and engaging with the ideas only really takes most people so far. Ultimately, you're just compelled to obey or agree. And the title of this event is Trust Me, I'm a Scientist, which I thought was interesting, because in many ways it runs counter to what science is about. The creed of the UK's National Academy of Science, the Royal Society, is diametrically opposed to it, for instance. Their motto is nullius in verba, which is the Latin for take nobody's word for it. It was chosen by the Royal Society's founders because they wanted to establish scientific facts free from the influence of, say, for instance, religion and politics. But I still think today it's a really good shorthand for what science is. It's organised scepticism. And it's really worth emphasising that because often we think of science just as a series of facts, and it's really not. Science is a way of finding things out. It's not a canon of knowledge. Even the most established facts are in essence still provisional. They're open to being disproved through experiment, and that really is the heart of what science is about. And obviously there's a limit to how far you can take this. It runs into problems in the modern day for a layperson like myself, actually. I'm not a scientist. For instance, I believe the Higgs boson exists. I haven't seen it for myself, I haven't touched it, I can't touch it. I can't even pretend to follow the beginnings of the physics and maths that describe it. But I still believe it's a real description of the fabric of the universe that we all happen to live in. So why do I believe it? Am I just, in fact, taking a scientist's word for it? Not quite. I think the reason I believe it is because I have a certain degree of faith, which is a dangerous word, in scientific enterprise. I know that for every scientist with a grand claim, there are hundreds more waiting to take him or her down. I know that the grander the claim, the more evidence required to fend off attacks. And I know that in the scientific community, prestige comes from publishing your ideas and findings precisely so that other people can try and replicate them or disprove them. Science is full of people who have the same impulses and problems as the rest of us. Scientists can be capricious, they can be ambitious, they can be arrogant, and they can be terribly biased. The scientific method is there to take account for that. It means ideas and findings have to be scrutinised by people who don't share your ambitions and don't share your motivations and don't share your biases. And the reason that's so important is because I actually believe those biases and motivations are incredibly important for science and for society. To take one example, think of Norman Borlaug. I think he's one of the unsung heroes in many ways of the 20th century. He's been called the father of the Green Revolution, mainly thanks to his work on varieties of food crops that give high yields and are more resistant to disease. And he's been credited with saving the lives of over 1 billion people. He was a plant scientist and an agronomist. Think about why he did his work. Was he simply dispassionately interested in how plants grow, and was it just a mere coincidence that his work is relevant to the lives of billions of people? No, he was a humanitarian. He said, and I quote, "Without food, man can live at most but a few weeks. Without it, all other components of social justice are meaningless. Food is the moral right of all who are born into this world." Borlaug felt he had a moral obligation, and his science was informed and indeed driven by that morality. To take a more recent, perhaps slightly more contentious example, how about David Nutt? He was a scientist who was sacked from his role as an independent advisor to government for speaking out on why he felt current drug policy was misguided, in an episode that I think is forever doomed to be called the Nutsack Affair. David Nutt still goes to pains to point out that ecstasy is less dangerous than some other drugs in Class A. He should, and therefore should be downgraded. He talks about why cannabis probably shouldn't be in Class B and how alcohol is probably not regulated enough. If you speak to him for any length of time, it becomes very clear very quickly that the reason he continues doing his scientific research and continues speaking out on these issues is because he cares deeply about the impacts of these drugs. Again, he's not some dispassionate egghead sitting in a lab robotically finding out facts about the world. He does it because he wants fewer lives ruined by jail and by drugs. And to my mind, it's entirely right that based on his research and based on his moral stance, he then goes out to influence public debate based on the moral position that he holds. The important thing is that facts and the opinions of these scientists should be open to scrutiny and to challenge. If they're telling you that, say, based on their research, we should be changing our behaviour or our laws or our public policies in X, Y or Z way, then it's entirely right that their evidence and their decisions should be interrogated and questioned. Again, it goes to the heart of what science is about. The more it's scrutinised, the better it is. So the debate should be how we can improve that engagement and scrutiny. And I hope that's what we can discuss for the rest of the afternoon. But I'd like to end on a historical note to show the kind of the pedigree and the heritage of this entire debate. In the 18th century, Thomas Malthus wrote about his now infamous Malthusian crises. He was worried that someday, probably quite soon, mankind's propensity to reproduce would outstrip the Earth's ability to provide for us. And we'd have a massive population crash, famine, all sorts of other disasters, which are obviously very relevant to some of the debates we're having today. And because of those fears he proposed some fixes, such as encouraging people to marry later so that they'd have children later, lowering the overall birth rates. Malthus used scientific facts to endorse specific policies, in other words. And I thought Leo Tolstoy gave a great riposte to this. This is in the late 19th century. He wrote, "It would seem as though Malthus's ideas were scientific deductions, and that those ideas had nothing in common with the instincts of the masses. But this can only appear so for the man who believes that science, like the church, is something self-contained, liable to no errors, and not simply the imaginings of weak, unerring folk. who merely substitute the word science in place of thoughts and the words of people for the sake of impressiveness. And I think I'm with Tolstoy in this one. I think that scientists, just like the rest of us, are weak and erring folk. They, like us, will be wrong on some things and right on others. But by engaging with science in public discourse, we can make sure that the science we actually end up with in our debates is not, as Tolstoy put it, simply the thoughts and words of people called science for the sake of impressiveness.
Turn it over to Roger.
Okay, thank you, Nina. I'm here today. Nina's introduced me in terms of my academic work and my research, but I'm also, in the past 2 years, largely spurred by controversies that have come up in the field of psychology and in other fields of science. I've become very interested in the problems of methodology in science and how we communicate with the public and how scientists communicate within a scientific field based on what they choose to publish and what kind of biases exist in the publishing process and in our communication with the public. So it's on this basis that I've agreed to be here and share some of my thoughts about what's going on in science right now. I have to say it's a very exciting time to be in psychology on these grounds, and other fields are also feeling this, this kind of questioning of the normal way that scientists have been going about their business. For example, biomedical sciences. In that field, perhaps for the past 5 years, and certainly in psychology for the past 2 years, attention has been drawn to the false positive problem, the idea that scientists, when we present our data, when we present our findings, tend to emphasize findings that make a nice, neat package, a nice, neat story. And so you may run, let's say, 5 studies testing a hypothesis, and 4 of those studies will come out in support of the hypothesis, right? People in the experimental group will show a higher level of whatever outcome you're testing than people in the control group. And that 5th study just doesn't quite make it. Perhaps they're about equal, or perhaps the experimental group is higher, but it's not statistically significant. There's a tendency in publishing for scientists to take that 5th study, the one that by itself doesn't support your hypothesis, and quietly put it in the file drawer and send the other 4 for publication as a strong package. And what this, to me, there's nothing sinister about this, I think, because it has to do with a very basic human tendency to deal with information. We're very bad at dealing with statistics, with probability, and with different degrees of uncertainty. We like to think in terms of yes, no, and then this undefined maybe. So we're not very good at saying, well, 80%, 90%, 95% probable. And especially when you have a contested debate, if one side comes out and says, look, 80% of studies show this, the other side is equally likely to come out and say, okay, but 20% of studies show the other thing. And in effect, they argue about the numbers. And what it appears to be in the eyes of the public is just one side says one thing, one side says the other thing. There's not an emphasis on the preponderance of evidence. Rather, there's an emphasis on, can I make a clean, consistent story, and let's forget about the part of the story that doesn't support this. And I think we need to change this, because this doesn't sound right when you explain it to other people in the general public. So, for example, if you have a body of literature and it's reported, and people who are on one side of an issue point out things that go against the grain of the body of literature, there's very little work out there in communicating with the public to help them understand that maybe what's needed is a meta-analysis, to look at the preponderance of the evidence, to look at exactly what kind of risk that we're taking. And I think that this is as true within science, when scientists try to make their own career, when they try to promote their own ideas. They often are guilty of not letting the whole truth shine through. It's not that they're covering up truth that is going completely in the opposite direction. It's just that they are making their own case look sharper, look neater, because skeptical minds in psychology will point, let's say, to that 20% of the studies that don't support the overall hypothesis and say, well, what about that 20%? That doesn't look good, that doesn't look pretty. We're going to reject this paper, and we're going to go with a paper that has 4 studies that all are significant and all point in the same direction. And I'll be glad to expand on this later, to answer questions about what's going on in science today. But This is the main reason for my being here, and this is just the position I want to get across to all of you. Thanks.
First of all, it's important to dissect what trust means. Trust is usually specific, it's not generic. And so we see these polls on groups of people, do you trust scientists, doctors, politicians, journalists? But the truth is that trust is actually specific to individuals and contexts. And as Nora O'Neill has said, do you trust journalists to tell you the football scores? Actually, you do. And most of the time they get them right. Trust in science, I think it's very important that we distinguish trust in the scientific method from trust in individual scientists. And scientists are human, like any other humans, and they have the full range of human strengths and weaknesses. Some scientists are very good scientists. Some scientists, frankly, are rather bad scientists. And if they make comments about computers, well, judge them. And some scientists, I'm afraid, are criminals. So I think we need to dissect the scientific method on the one hand versus the behavior of scientists on the other. And Imran's already set out some of the issues about the scientific method. And the method itself is very powerful. It's actually about asking questions. It's about generating hypotheses. And it's about doing experiments that might refute those hypotheses. But it's important to understand that there are limits to science as well. So we can model climate change, we can model epidemics, but it's very difficult for anyone to say in a year's time what the weather over the Barbican is going to be, or indeed whether I'll get flu as opposed to any of the rest of us in the audience. Those are things that are too complicated for science to model, at least at the moment. And I think the point's already been made well that science at the cutting edge really is about dealing with uncertainties. And what science is all about is reducing uncertainty by force of experimentation. And one of the things that scientists realize is that measurement and data collection has errors, and that's what statistics is all about. It's about descriptions such as the confidence limits of data. And I think all too often science is conveyed as science says this, rather than we don't really know. And I think one of the most difficult things of all is that I think science, and we've just had a little bit of discussion from Roger, says this is the most probable explanation of a set of phenomena. And the problem is that that then gets converted in public discourse into, that means I can believe what I like. And those two statements aren't the same thing. So if there is a 10% confidence limit, but it's 90% that something is associated, the numbers are the numbers, and you can't actually believe what you like. And it's slightly curious, actually, because I think most of the population would expect scientific method to be applied to medical practice. And it's odd that we don't have the same expectations for other areas where science could work equally well, like educational method, for example. We've had some examples from recent public engagement, and Imran's talked about the Higgs boson. There was quite a notable spat recently about whether neutrinos can go faster than the speed of light or not, and it turns out that they can't, and that was caused by a wiring, a loose wire. Cancer genetics is something that is generally communicated very well. And I mean, why do people happily accept these? And part of it, I think, is they don't really have any reason to distrust them. The Higgs boson doesn't immediately affect any of our lives. It's obviously extremely important, and there may be all sorts of applications at a later stage. But science engagement, I think, is much harder, and trust is much more question when it comes to those things that affect our lives directly. So changes in climate, the introduction of vaccines. And I think that one thing that we need to distinguish is between two sorts of questions, and what my erstwhile PhD supervisor, Peter Lachman, called polable and non-polable questions. So a polable question is something that you can actually vote on, whereas a non-polable question is something like the speed of light. You know, we can have as many opinions on it as we like in this audience, but actually there is a correct answer. And there are a series of questions. So the extent of anthropogenic climate change is actually another non-polable question. You may be able to wish to believe whatever you like, but actually there is an answer to that. And indeed, the efficacy of homeopathic medicine falls into an unpolable question. You may believe what you like, but but actually there is a correct answer. And the American politician Daniel Moynihan said it very nicely, which is that we may all be entitled to our own opinions, but we're not entitled to our own facts. When it comes to social policy, science can be very helpful, but actually the policy decisions then become polable. So, for example, you can test criminal sentencing policy by controlled experiments to compare whether, for example, a different type of custodial sentence or a non-custodial sentence might affect reoffending rates. But then that's only part of the decision that any politician takes, because there is actually an element of retribution in the justice system, and so ultimately sentencing is an issue that is pollable. You can vote on it. So coming to scientists and different types of issue, when scientists comment on science itself, frankly, that can be done well or it can be done badly. And the biggest danger, I think, is of hype and simply putting forward not very good science. I think science is much harder when it comes to emerging issues, because scientists, and I'm conscious of what will happen to me come April the 1st next year, are often wheeled out to comment on extreme events, which may be biological or physical, or to comment on new technologies, so genetically modified food. But actually making a general comment on genetically modified food doesn't make sense. It's what food, genetically modified with what gene, for what purpose? And there are some examples that are good and other examples that are less good. So I think when it comes to scientists and comment in the media, you really have to distinguish the scientific advice from the policy decision. And drugs is a very good example of that. And a scientific advisor needs to be clear when he or her is giving specialist scientific advice, and then when politicians have to make the policy decisions. Thank you.
If you'd have asked me this question 20 years ago, do you trust the science? I'd have said, yeah, absolutely. Scientists are interested in questions of nature, carving nature at its joints, as it's been nicely put. And if you try and cheat, if you try and manipulate science for political or personal ends, the facts of nature will expose you as a cheat. And I also argued that in any case, scientists are not motivated to cheat. They're basically motivated to understand, not motivated to make stuff up. Today, I'm not as convinced by that argument as I was 20 years ago. I think there are now real problems in science, and they boil down to science being used instrumentally for policy making and instrumentally by scientists themselves to advance their own interests. So the first trend to this is that encroachment of science into politics and policy making, and the encroachment of politics into science. It's entirely normal now to hear politicians talk about evidence-based policy. Evidence-based policy has a nice ring to it. I mean, who would want a non-evidence-based policy? Well, as it happens, to some extent, I would. Not that I don't want policy to be informed by evidence, but I don't think science dictates policy. So yes, science can tell us that smoking is bad for our health and will shorten our lives. But science cannot tell us that therefore we should stop smoking. We can decide that we prefer to smoke and have shorter lives. Science can tell us that the planet is getting warmer. But science can't tell us that we should therefore stop taking international flights so as to stop the planet getting warmer. We can decide that we will live with the consequences of it and so forth. But increasingly, scientists just don't see things in this way. So science has been used, for example, to justify smoking bans, to introduce carbon taxes, to encourage recycling, to make parenting classes mandatory, to eliminate chips from school meals, to justify all of us eating 5 fruit and veg a day, to maintain the upper abortion limit at 24 weeks in the UK and to reduce it to 20 weeks in Nebraska, and to justify a whole host of actual proposed policy decisions around lifestyle, health and children. I'm not particularly interested in the rights and wrongs of these in the narrow sense of whether or not, for example, it can be demonstrated that smoking indoors is bad for your health. What I am interested in is what happens to science when it's used in this kind of instrumental way. And one of the things that I think happens is that science stops being a dispassionate search for the truth and becomes a vehicle for justifying policy and basically for having a social impact. So a dispassionate approach to smoking, for example, would obviously include an examination of risks. But it would also include an examination of benefits, including psychological and psychosocial benefits. Considerable effort has been made to associate smoking indoors with negative health outcomes, but it's not been met with the same effort to understand the negative effects of forcing 1/3 of the population to intermittently stand outside. Similarly, while much effort is made to understand the negative impact of global warming, very little effort is made to recognise the benefits of being potentially able to dictate the climate. So the encroachment of science onto policy basically creates an agenda that has aims other than the enhancement of knowledge and the advancement of understanding, and that can distort the path of science. The other side of that is what scientists themselves are actually doing. So there's a popular view of scientists as being eccentric nerds with wild hair, pursuing esoteric, possibly pointless, certainly difficult ideas for decades at a time. But this actually is rarely matched now by live scientists. Today's scientists are increasingly asked to view their work as an engine of economic growth, as a means to propose or justify policy, as a platform for increasing the status of their department through the Research Excellence Framework, and as a means of bringing in grant money and other funds into their institutions. The rewards for performing these duties include lucrative commercial partnerships, recognition by politicians and the media, and often rapid career progression. The penalties for not performing these duties include increased teaching and admin load, salary freezes, an end to career progression, and ultimately being forced or squeezed out of research. So given these pressures, it's perhaps not surprising that actually there have been a number of high-profile fraud cases in the past few years. Most of you are probably aware of Wang Woo Suk, publishing a paper in 2005 on the creation of stem cell lines from the skin cells of patients, potentially revolutionizing individualized medicine. In the same year, he reported that he successfully cloned a dog. Both claims turned out to be utter fabrications, and he was prosecuted for fraud and embezzlement. In 2009, a lady whose name I can't pronounce falsified data linking pesticides to neuronal mechanisms involved in Parkinson's disease. She's subsequently been sacked and signed a voluntary exclusion agreement in the USA. Last year, Mark Hauser, a Harvard professor of psychology and evolutionary biology, was forced to resign after accusations that he falsified data relating to how cotton tamarins might learn rules relevant for language. Last year, Dirk Smeesters, a social psychologist at Erasmus University, was also caught massaging his data to support different influences on colour on consumer behaviour. And also, Diederik Stapel fabricated findings, released 30 papers, including a famous paper about how untidy environments encourage discrimination. How much of a problem direct fraud is difficult to estimate, but when asked anonymously, but directly, whether they have ever fabricated, falsified or modified data or results at least once, 2% of scientists polled said yes. And that seems to me a pretty high number as it happens. And it's been reported recently that almost half of all papers retracted from scientific journals were retracted due to fraud or suspected fraud. And retractions have increased about 1,200% over the past decade. So I'm less inclined to believe that fraud is less of a problem than it was 20 years ago. I'm inclined to believe that fraud actually is on the increase. But there are related dubious practices that don't quite reach the level of fraud. So, for example, there's a problem of researchers who will selectively only publish parts of their experiment. So let's say, for example, you believe that people feel happier after eating fruit, and you measure happiness after people eat a banana, then an apple, then a plum, then a strawberry, and then an orange. And you find that people get happier after they've eaten the strawberry, but not the other fruit. You publish a paper with a snappy title, "Strawberries Make Me Smile," and you fail to mention the other fruits in your paper, thus increasing the apparent effect by that omission. And this seems to be happening quite a lot. Single hypothesis papers that are successful have increased by 22% in the last 15 years. And there are a number of related dubious practices to this as well. Mining your data, not working so hard for the control conditions, running lots and lots of subjects until you find the effect you want and then stopping, and so on and so forth. And then finally, I'm almost out of time, there's the problem of spin, which is exaggerating the meaning and implication of a finding. So a team of French researchers have assessed 500 papers and associated press releases and found that 40% of the papers and 47% of the press releases included spin. That is basically exaggerating the effects or stating an implication effect that was not actually correct. So I think scientists function best when they're motivated by the joy of discovery and the desire to understand something just for the hell of understanding it. But I think there are motivations now that have entered into science and that are changing the way in which scientists are working. The current motivational structure for science is badly at odds with that vision of just understanding for the sake of it. And science and scientists are therefore doing things that they shouldn't do.
So I'm going to come out to the audience in just a minute, but before I do, is there anything the panelists would like to come back on briefly? Mark?
Yes, absolutely. Quite a few things, but I mean, you can guess which talk I'm going to come back on. The idea that science shouldn't be used for instrumental purposes is actually completely ridiculous. We live in a room which is completely modified by the products of science and engineering. The issue about smoking is that it's not the scientists that actually implemented the social policies. What science does, it provides the information to allow policymakers to make decisions. And it's actually the Houses of Parliament that legislated to ban smoking in public places, for example. So, I mean, the point about science, and where I think I would agree with him, is that I don't necessarily think scientists have any particular wisdom when it comes to the social policy decisions that flow from their research. But the idea that science shouldn't be used for instrumental purposes is just frankly completely ridiculous.
I'd broadly agree with what Mark just said, perhaps with the caveat that although scientists might not have any particular wisdom, I think there is a role for them in the debate to say that they should be at liberty and indeed encouraged to talk about what impact their research might have. But I'd also just come back on the idea that scientists are at their best when they're doing dispassionate research with the aim of greater understanding. Because I really don't think that is the case, or indeed has ever been the case. I think scientists have always been driven by a desire to have particular impacts, whether that's prestige for themselves or whether it's a nicer chair at their university. But just to pick one example, so in environmental research, you talk about having data about how anthropogenic climate change is changing our world and the people that discover this, and look at the data. Think about why they're doing it. Are they really just dispassionately interested in what they're doing? I don't think they are, because why would you bother in the first place for any bit of research if you didn't care about it? And I think that care and that ambition and that motivation is really key to why we do go and understand things.
It's true. Scientists do work best when they're impassioned. They do work best when they have, in a sense, something to prove. And this has been recognized by philosophers of science, like people like Paul Dirac and so on, for many years. But I think nowadays, and Stu very nicely filled in some of the things I initially wanted to say about the climate of science today and all the fraud cases, retractions coming up. And I think what we're seeing is, all right, we can use this passion to generate research, but then we need more of the checking of research. We need more looking at research, trying to replicate research. And the problem is there's nothing glamorous about checking. There's nothing glamorous about doing replications. There were cases, for example, a well-known paper last year in my field, Social Psychology's top journal, Journal of Personality and Social Psychology, purporting to show that precognition exists in a series of priming experiments where you can have people responding on the basis of a trial that is to be presented a few seconds into the future. And, well, there are a lot of things I could say about this paper, but the thing that jumps to mind in this context is that a group of scientists from the UK tried to replicate these studies. They could not replicate those studies. They submitted that paper to the same prestigious journal that published the original article, which of course garnered a lot of attention, and the journal refused on the grounds that we don't think replication attempts are groundbreaking enough to publish in our journal. And eventually they had to get this published in another journal. And over the past couple of years, with these cases and other cases, we've come to see that this maybe is not an acceptable answer. I think most of you in this room would not see this as an acceptable way for a communication outlet like a journal to deal with non-replication. And so the question is, have we become, as scientists, too entrenched, again, for many of the reasons Stuart mentions, careerism, pressures from our institutions to produce research and to publish in the top journals, but has this whole enterprise become a kind of gone off the rails slightly in the sense that not enough people are doing the hard and the dirty work of checking, of replicating, and most importantly, of making non-replications and replications known.
Yeah, great.
Can I just come back on the fraud thing? Because I think the two presenters on your right, Rogers and Stewart, are both guilty of bad science in the way they presented the paper. Firstly, there's no evidence, actually, that the incidence of fraud is going up. I think what is clear is that we're looking harder for it. But those of us who have maybe been around for a long time will remember the case of the midwife toad, which happened very, very many years ago. And just the paper that you reported, which was published in the Proceedings of the National Academy of Sciences just in the last week or so, almost half of the retractions were in fact from a very small number of labs where there was a very bad egg who just published paper after paper that got retracted. I think what we are seeing is more policing of the system, more retractions, but I don't think there's any real evidence that the actual rate of fraud has gone up at all.
Okay, Stuart, do you want to come back briefly?
Yeah, well, at the risk of being more ridiculous. So I think I don't quite agree with you, Mark. So as it happens, the British Medical Association do actively lobby the government to change the law on smoking. I mean, most notoriously, they tried to get the government to change the law on smoking in cars when there are kids in the car. Now, they got caught out because they misinterpreted or made a mistake in the level of carcinogens left behind by smoking in cars. But it's an idea that's not dying, it keeps coming back. So there is, I think, a problem with advocacy-based research out there. I take the point about an agenda. It's difficult to find a period in history where there's been no agenda informing science. Obviously, Second World War, massive agenda informing science, and we had some tremendous breakthroughs, radar, sonar, and so on and so forth. But I worry about the agenda that's informing science today. It seems peculiarly petty and unpleasant. And as it happens, I would argue that there isn't a lot of science that's done just for the hell of it, but increasingly we're under pressure to not justify it in that way. So I reviewed a lot of grants for my sins on rat brains, and I'm particularly interested in barrel neural formation in rat brains. And I'm tired of researchers telling me that studying the barrels in the cortex of rats is going to help blind people read Braille. It's not. It's a totally made-up thing that they just put in there to try and justify the reasons for their research. They don't need to do that. It's actually fun, interesting, good stuff to do on its own merit, and we shouldn't discourage scientists from doing that.
Thank you. Mark Walport mentioned educational policy. I saw Ben Goldacre speak at the Festival of Education a couple of months back, and as everyone probably knows, I don't know if he's here today, but he talks a lot about pseudoscience and so on. And there's a lot of that he says I agree with, but I think at this festival he then went a bit further and started arguing things like the question of whether we teach phonics should be decided by double-blind trials. And now I think there might be something useful they can tell you, but I think in arguing that, he's sort of forcing out all the philosophical, pedagogical questions that go with that, and that really worries me. I think it's sort of an example of what Stuart was talking about science overstepping its mark a bit, and it's going beyond saying trust us, it's saying do what we tell you.
A lot of the sort of issues that seem to be coming up seem to be that the scientist was acting as an intermediary between the product of the science that they have done and the possible implications of the information that they have discovered. And a lot of science in this country is, of course, put behind paywalls. It's put into journals that do not have access to the kinds of people that need to actually have access to that information. And I'm wondering whether the panel believes that the current sort of method of doing science in the UK is currently fit for purpose, and whether that method is actually what's producing a lot of the issues with regards to trust.
Mark Walport gave a typically lucid description of polable, non-polable evidence-based science. I wish him all the best of luck for April, but I think the real world may be rather more murky. There was a nice comment, I think, we're all for evidence-based policy. Ministers, of course, have an enormous bias towards policy-based evidence. And one of the extraordinary things, I think, to take a recent example, is the badger cull. Now, I have no particular axe to grind one way or other over badgers. Either they're spreading it or they're not, or you gas them and shoot them or you don't. But what was, I thought, quite extraordinary there were unequivocal statements by chief scientific advisors on both sides. Either that a badger cull wouldn't do any good at all and would probably do harm, or that it would do good. And I wonder whether Mark would prefer not to comment on that particular controversy.
I think it's worth considering how life has changed for the scientists in the past 40, 50 years. In the 60s and 70s, when there was a lot of expansion and new universities and so on, it was very secure occupation, and we got tenure and so on, and when units were built around really clever leaders in science to do what they like, basically, academic research science. And there was always somewhere to go when the units closed. But it's become a very, very insecure profession, and people are often on soft money and losing their jobs and not getting grants. And most scientists actually love what they're doing because they're still doing it with all that insecurity. The other big change was the transition from basic research to applied research, when you had to write grants instead of, really pursuing something that you're passionate about, but then it had to be about a solution solving cancer, or you had to put in something applied and hope that you could do enough of that to justify what you were doing and still do what you like. So I do think that the misbehaviour of scientists today is related to that insecurity, that it's very competitive, and scientists now involve the media, a lot of media hype, to support what they do. They're eager to get on stage, and I think that that a lot of things that scientists do that aren't as good as they used to be, or as rigorous as they used to be, is related to that insecurity of the profession.
The panel have been talking a lot about scientific fraud, but surely a much bigger problem is it's a more subtle and insidious problem, but the problem of conflict of interest and looking where scientists' funding is coming from, particularly in industry.
Could the panel comment on the growth of organisations like the IPCC, which is actually, of course, a political entity coming out of the UN, which did something quite unusual. It tried to round up all the scientists and tell us that the world had a vast majority of scientists believing this particular thing, and then an awful lot of the summary papers were actually written by environmental enthusiasts who were biased in favour of the idea that there should be action on climate change. So it was, if you like, a blurring of politics, science, in something that's very important because it's costing us a lot of money, rightly or wrongly.
Just to kind of possibly look at this from the other side, so from the political aspect rather than the scientific one, which I think is the flip side of this discussion, there is a desire amongst mainstream politicians to essentially have the right answer. They're scared of having a debate and arguing in front of the public because the public don't really want to listen to them, don't trust them. And so they're out looking for a hard and fast answer to every situation. And to be honest, Mark, I think that education policy is a pollable question. It's not something you can resolve scientifically, abstractly. It isn't a natural scientific question. It's a social question that has to be resolved on the level of politics. But like with drug policy, like with any number of these things, government ministers don't feel confident to be able to go out and say, I have a moral political belief, and try and win people over to it. They want to browbeat people with scientific facts and damage science in the process.
So on education first, science can actually tell you how to teach. What it can't tell you is what to teach. So the content of a curriculum is something that has to be assessed by human judgment. But actually whether there is one method of teaching young children to read that operates more effectively than another is actually a scientific question. It can be approached by a controlled trial. I don't think you could do a double-blind trial on the particular question you suggested, and it may be that the answer will be different with different languages and different scripts. But actually, it is a scientific question, and it can be addressed. There was a thing about open access. Well, absolutely, you're right. It would be much better if science was published in a form that everyone could have access to it. It's something the Working Trust has been working on for years. Policy-based evidence, well, that clearly is a challenge. I'm certainly not going to comment on badges, but what I will comment on is the fact that scientists are often asked to comment in an area where there is uncertainty, and I think the real message is to get across the uncertainties, and then, as I say, it is for the policymakers ultimately to make the decisions. From the middle, it was a rather bucolic view of the research world, if I may say so. I don't think there was ever a time when research wasn't a competitive business, when there weren't insecurities about where research money would come from. The research volume has grown and the number of people involved, but it was always quite tough. And I think we shouldn't get into huge battles about basic versus applied research. We need both. The judgment is about, roughly how much you spend where. I've never heard anyone argue that we shouldn't fund blue skies, sometimes called curiosity-driven research. If you ever wanted a defence of it, just listen to John Gurdon when he got his Nobel Prize a couple of weeks ago. On conflict of interest, the issue is transparency. There isn't anything intrinsically wrong in private sources funding research, but you just have to be absolutely clear who has funded you. And on the IPCC, remember that we had a Royal Commission on Environmental Pollution, and indeed there have been Royal Commissions in the UK going back to the 19th century. So the idea of gathering together groups of experts who can assemble the evidence and comment on it And I don't think the IPCC they weren't told to do something, they were actually providing the best evidence on climate change.
I profoundly disagree with Mark on this. I'm really shocked that he thinks that education can be dictated by science, or even that science can tell us the right way to do education. Because even education doesn't exist in a vacuum. So let's say, I'm going to be very crude, we demonstrate that one way of teaching kids to read means they can read 100 words at the end of 6 months, but another way they can only read 50 words. You might think, well, obviously we'll go for the way that makes them read 100 words, but maybe that means that they get trapped in school for an extra 3 hours a week, and maybe it'd be better if they went out and played for those 3 hours a week, or maybe the parents just don't like that particular way of doing things, or whatever. There's a whole host of things that can come into it, and the idea that the science knows best is actually pretty oppressive and pretty unpleasant. It's kind of anti-human in that sense. And I'm surprised, Mark, that you can't see a bit more of that. I'm also surprised that you have such a rosy view of how science is being done today. I mean, I accept that a Nobel Prize winner might have done curiosity-driven research for a long time, but he came of age during a different period. You know, my PhD supervisor took 8 years to do his PhD. He had a grant for 3 years, and at the end of that 3 years, he hadn't really found anything, so he wrote to the Research Council. They said, yeah, sure, take another 3 years. At the end of those 3 years, he was kind of finding out a few things. He wrote to them again. They said, yeah, sure, have another 3 years. And then at the end of 2 years, he's like, I'm done, and he submitted it. You cannot do that today. Our PhD students have to be finished inside 3 years, otherwise they get basically kicked out of the institution, and the institution gets penalized. And on top of that, if they don't have 2 or 3 publications under their belt, they're going to really, really struggle in this labour market. So we do and are creating a situation where you do not have the time to pursue something for 5 to 6 years and see what happens. You have to produce something that's interesting, innovative, counterintuitive, with a positive finding, very quickly, get yourself into the best journal that you can in order to survive. And that is a recipe for doing science in quite a different way from the way in which it was done before. And it's a fairly new development. It's the last 10, 20 years that this has become such a pressurized environment.
It's a question about open access and paywalls, and are we actually excluding people from the debate if they can't gain access to this research we actually, a taxpayer, have funded? And I thought, Mark's point was a very good one, that one of the things the Wellcome Trust and lots of other people are doing is trying to remove the paywalls, bring the walls down so people can look in. But I think that's not enough in some ways, because I studied biology to a degree level and have a decent understanding of stats and all other things. But faced with a latest paper in Nature, even Nature this week, I would struggle to understand more than the basics of it. I think just having them there to read isn't enough. We need scientists actively going out and explaining the research to the general public so the public can understand what they've paid for. And actually that requirement to engage on your research is now a fundamental part of the Research Excellence Framework, which is how research funding is awarded. And I think that's a good thing, actually. I think people should have to go out and talk about the value of what they do, because given that we're paying for it. And I thought the question about education really does go to the crux of the debate that we're having, in that, yes, I think you can do research into finding out how effective phonics is. I think just saying, well, some people think it's a good idea, some people don't, let them get on with it. You could take that approach, but actually, given that these are our collective children, I have children with you, obviously, but there are collective children that these policies are being used on. It's our taxpayers' funding that's being used to pay for these policies. And I think we should be able to say, here is the evidence one way or another on how effective it is, and then not say, well, therefore, let's do this, but have that contribute to a wider public debate. And I think, Stuart, you're completely right, that even if the evidence says policy X is more effective or more cost-effective than policy Y, if people, for one reason or another, prefer the first option and they vote for politicians that are going to push them, then I think that's perfectly fine. And I really don't think you'll find a scientist saying otherwise. I think that there is an element of a straw man by saying, we want policy to be informed by evidence but not pushed by it. And I really don't think it is pushed by evidence. I think it's pushed by people with agendas, but that's different.
I certainly agree with Imran about publishing, that it is a good thing to make our research available for people. It is also a good thing to make it really available to the general public, in that not only to to spit out the papers as they are written with the scientific jargon and, you know, a corpus of maybe 100 or 200 papers and expect people to go through that, but actually for scientists to spend time to come up with presentations, summaries of the research. And this also makes for better science because you're no longer just pointing at the one paper that says, aha, we found this in one study, and it makes the news, and there's a big, you know, press releases go out. The university is very happy to put out press releases on that, but then 5 other studies find the opposite. You don't get so much of a hullabaloo about that. And if science itself were more tolerant and more focused on what we call the meta-analysis, the study of studies, the accumulation of evidence across numerous individual publications, and if we put out more publications on that basis, some fields of science do. Some fields are very good at that. I think in psychology, there's more than one journal that's dedicated to writing accessible summaries of any given research topic. Of course, what you have to accept then is the possibility that the person writing that summary has a kind of an agenda, and this is why methods have been developed, statistical meta-analysis, for systematically going through the literature, not just a narrative review where you eyeball the literature and say most studies say this, but actually adding up the numbers of cases in each study and the effect sizes of each study, and quantitatively coming up with some kind of a result at the end of it that summarizes the state of research. So on that basis, of course, it's a right. If your money has paid for research, you should be able to access it, but then there's also the question of expertise, and do you really have the time to wade through 200 studies and learn up to a PhD level how to interpret those studies? I think there needs to be a little bit more there to have public access. And on the issue of whether academia has gotten harder, I think it's gotten harder. And you know, I've been in this maybe, I don't know, 20 years or so, and since I was in graduate school, just looking at old journals in my field. Again, I'm only talking about one field that I know very well, social psychology, but there used to be more tolerance for just papers that wouldn't have a single conclusion. They would end with a statement like, well, it's complicated, we did this study and that study. They kind of contradict each other. And due to all these pressures, I think, and actually I've run numbers on my own discipline just looking at the number of slots for people to publish versus the number of people who are attending conferences in my discipline. There is actually empirically a pressure. The number of slots in journals is not rising at the same rate as the number of people who are doing research. And the inevitable result is that the paper with 4 perfect-looking studies will drive out the more honest paper that reports all 5 studies that they ran and only 4 of them came out significant in the direction indicated. Scientifically, that's the 4 out of 5 is still a pretty good indication that you're onto something out there. But just from the point of view of people's intuitive, instinctive mind, yes, no, or maybe, that looks like a maybe. That doesn't look like a yes. And I think even scientists are prone to this kind of thinking when it comes to comparing 2 different pieces of evidence.
Okay. Hi. I thought the pollable, non-pollable questions distinction is potentially useful, but I want to make 2 brief points on it. The first one, I think, is that there are very few questions that are simply non-pollable, because even if you say, for example, earlier today we were discussing the outcome of bad parenting on, as it turned out, rats, but with the implication that you could learn something for people. But even among rats, the idea of what constituted bad rat parenting and of what constituted good outcome was something the scientists had decided before they ran the experiment. And certainly with humans, you can see it be much more complicated. And you could ask yourself, was it a worse outcome for a human child to grow up having not been read to very often and left to fend for themselves, perhaps more than you'd like? Or is it a worse outcome for them to grow up in a world where the government tells your parents how much to read to you, for example? So I think it's useful, but we should be wary of how purely non-pollable any question could be. But the other thing is, I think you have the emphasis the wrong way around. You seem to be saying too many people try to make non-pollable questions pollable. But I think actually it's the other way around more. And I don't think this is because evil scientists are trying to take over the world by any means. I think much more the pressure comes from outside science, that a lot of people are very keen to make pollable questions non-pollable, because there are very few... I think we've found this weekend it's quite hard to get even a common ground to discuss issues of politics and morality. And it's quite nice if you can come back to something like scientific evidence and maths and statistics that seem very clean and certain. And I think that is part of the drive to evidence-based policy, is that it gives you something that is undisputable. You can say, well, look, this is the evidence, and you can agree or disagree about what we should do, but here it is. I think there's a great drive in the lack of political certainties or common grounds or principles to look to science for principles on which we can agree to make decisions on. So I think there is more of a drive to make pollable questions non-pollable and thereby avoid difficult debates about what we should do than there is to make non-pollable questions pollable and ignore the useful things that science can tell us.
I was just looking at the evolution from trust me. It's trust me, tell me, show me, prove it. And I used to work in industry, and we were being pushed at the prove it point. So you're just at the very start on the scientific side. And I think, I've forgotten her second name, Una, the lecturer, BBC lecturer, I think, went through that point some years ago. I think the question of motivation, I think, is really quite important. I think it was raised, and there was an implication that who funds, one of the, not the speakers, one of the audience, was important, and indeed it is, and the comment was transparency is the way to deal with that. And I think that's right. But I think there's another thing. There's something that actually Jim Lovelock, he of the Gaia hypothesis many years ago, commented that who would you trust to give you the best information on a topic and why? And that comes down to motivation. And just you think about what happens, whoever's saying it, what happens if they're wrong? If you work for industry, as I did, you get advice wrong to the company. It could go out of business. An individual scientist, if he gets it wrong, will probably still be in a job, and in fact has some incentive to hype the story to get better funds. So I think you need to look at the motives of the people making the comments. The science speaks for itself, but it's the comments. And scientists need to separate between, are they talking about the science, are they making a comment? And obviously once you get into policy making, it's a different area, but that is often very muddied.
Thanks. When I was listening to all the different things being said, there's a few things that came out, and the word integrity was something that really rang in my ears. You talk about sort of false positive problem, trust in the scientific method, and then these fraudulent papers that have been published. I'm an early career researcher, and it makes me feel quite worried that there seems to be a lack of integrity of people who are researching. Why are people researching if they don't care about the actual truths of what they're finding, and why are we even bothering?
I read something recently, which was a website that someone had put together, which had all the things that the Daily Mail said that you could die or get cancer from. And it was things that were like eating too much fruit, not eating enough fruit. And I was just going to ask, do you think that there's, to a certain degree, we don't care, like, I know that you're saying that people need to know, like, the balanced evidence, but do you not think that the public just don't really care about that? Like, they just want to believe sensationalist parts of science and these things that, because like it's kind of exciting in a way if they think that these things are bad for them and that kind of thing.
Is it not that there is too much science data out there? The public just seems to be so bombarded with the various results of various research and experiments carried out, and not enough scrutiny is given to actual scientific method and the social and economic benefits and impacts of that science. Speaking as somebody who works in science communications, I regularly have this problem. Just to give you an example, one project I work with is around fusion energy, and one myth that seems to keep coming back is that fusion energy is going to be sort of 30 or 40 years off, whereas the reality is far, far closer. it seems to me as a result, because of this sort of too much data, people tend to revert to believing some of the old myths and some of the old generic arguments, keep coming back to this, and aren't focused enough on the potential benefits and actual benefits of scientific research.
I'd like to ask members of the panel to revisit the issue with regards to David Nutt. Was this a case of the government not liking the outcomes of the evidence-based research that David Nutt did, or was it a case of the importance, as Mark Walport said, of maintaining a distinction between the science and the policy?
Okay. I quite like this idea of the scientists striving forwards, thrusting outwards and making policy, but I think I might be slightly biased. I'm slightly loath to, but I'm going to revisit the case of Andrew Wakefield and the MMR. And when we had a case which was quite obviously bad science, we fell apart. The medical profession fell apart. We had panics, we had pandemics, we had people who weren't vaccinating their children against what was well-established medical ethos. And I just it's quite an interesting idea that we are now, scientists are now producing evidence-based policy, but we need to look as well, what we want to produce and how we counteract and we work with politics as well.
Okay, well, I want to pick up the integrity point, because there is an element of a sort of when did you stop beating your brother, mother, whatever. Don't believe it. We heard the figure before that 2% said they might have fabricated something. Well, that means 98% didn't say that. Now, I don't think that was probably a very robust piece of research. But the truth is that, like doctors and other professions, most scientists have a very high degree of integrity, and bad science will out eventually. So I just wouldn't take it for granted when people say scientists don't have integrity. I don't believe there's any evidence in support of that at all. And I go back, I think, for my sort of final comment to, I think we really do have to distinguish between trust in the individual scientist and within the scientific method. The scientific method, when applied properly, is enormously powerful. That is what the Enlightenment was all about, and it pains me that we are in a position where some people are almost wishing to turn the clock back before the Enlightenment. When it comes to scientists talking out, just because someone says they're a scientist, it doesn't really mean they are.
There was a comment earlier that science is getting harder, and being A, not a scientist, and B, relatively young, I don't know what it was like in the old days, but one of the ways in which science has got harder is illustrated by something the British Medical Journal have done, and we referenced how they've actually been at the forefront of exposing scientific fraud and pushing for tighter regulations. One of the things they've done is ban any academic from saying in a research paper at the end of it in their conclusions, more research is needed. Because more research is always needed, and that's a completely fatuous thing to say. And what they say instead is, if you think more research is needed, say what that research is, say what the next study is going to be. And yes, that's harder than just saying more research is needed, but it's also better. So I think in some ways, science becoming harder is a good thing, and we shouldn't just say, it's getting harder, let's feel sorry for everyone. I thought a really interesting question that was posed just now was about the pollability question, and is there a move to having more things become non-pollable because politicians find it easier that way? And I think the kind of logical endpoint of that is not in science but actually economics. In the interest rates in the UK are set by the Monetary Policy Committee, not by elected politicians. They're set by a committee of essentially, academic thinkers who have an expertise in banking, and then decide this is hugely important policy for the rest of us. And I think there's an interesting comparison to be made between science and economics more generally, in that I certainly feel, as someone who's relatively well-informed, that I still don't really understand what caused the financial crash. I don't understand what the policies are that have either got us or are stopping us getting out of it. I don't understand how we can help shape our path into the future. And I think when you compare that to the situation we have in science, where ultimately all scientific decisions are made by MPs, not by scientists. Scientists inform the decision-making process, but they don't make it themselves. And also we, as the public, are much better placed to help almost decide our scientific and technological future than we are in terms of our economic future. So yes, things could be improved. Yes, we need to fight fraud more. Yes, we need to do engagement more. But ultimately, I think we're on the right track compared to some other fields.
I was really pleased when I heard that Mark Walport was going to be the chief scientific advisor of the government. I'm still pleased, but you've worried me just a touch. I'm not trying to make the case that science lacks integrity entirely. I'm not trying to make the case there's no good science out there. There's lots of great science. There's lots of scientists who have tremendous integrity and work, in actually pretty difficult circumstances to continue some really important and interesting stuff. But I do think something has changed, and I just want to pick up on this point that was made from the back about where does the pressure come from, and she made the point that the pressure seems to come from outside science, and I think it does. And Imran's made the point that we've always had this. Science has always been forced by agendas other than itself, and I've been asked about the influence of big business on science. And on the whole, I dislike influences on science that are there other than the pursuit of understanding for the sake of understanding, because it does create an agenda that's other than that and can distort the scientific process. The late Stephen Jay Gould was very fond of pointing out that we know an awful lot about Burgess Shale. And we know an awful lot about Burgess Shale because shale is important to oil companies. And if shale wasn't important to oil companies, we'd probably know a lot less about shale than we do now. Nevertheless, what we know about shale is true and interesting and useful, and still good scientific work was done on shale thanks to the generosity of oil companies around that issue. So there you can see quite clearly what the agenda is and how it's happening. I think now it's like the agenda is coming from a really pernicious, unpleasant direction. There's a view of human beings as being not particularly pleasant, not particularly well-behaved, not particularly responsible, a bit irrational. And so science is being used in a way to push people into behaving more like good citizens, to behave better, to do what they should and shouldn't do. And as soon as science starts to think that it knows better than what people themselves know, that, I think, is a real problem, and that I do dislike, and that agenda, I think, is a problem in science, both for politics and for science as well.
Too much data. Well, again, what I said before, that maybe the problem is not too much data, but rather too little summarizing of the data, and in particular, when it comes to the media reports, instead of university press offices trumpeting the latest groundbreaking meta-analysis, they tend to trumpet the latest groundbreaking single study. Maybe as consumers of the media, consumers of science, we need to be more aware that single studies actually tell us very little, and meta-analyses actually tell us a lot. And maybe the question is not too much data, but too little consolidation of data. As for the question, the early stage researcher who was concerned, it can be kind of soul destroying to come up against these issues and to hear these kinds of debates. I've seen many young crestfallen faces when I talk about these issues, but at the same time, I think the power is in the hands, in particular, of students, of early researchers, to try and change how things are done. And most of the things that undermine integrity are not out-and-out fraud. Very few of us are in the fraud business. That 2%, okay, maybe it's an underestimate. But I really believe that the few people who've been busted for fraud are, there are not that many out there. But what is more prevalent, and something to worry about even more, because it is almost normal in science, is this tendency to edit the results. And people don't think that they're doing anything wrong because they perceive a pressure that's immoral. They perceive, I can't get published even though I have 3 studies, they all tend in the same direction, but none of them individually reaches this magical significance threshold, okay? And so what I'm going to do, I'm going to do the analysis a little bit differently, and now voila, the significance emerges and I can get published. I think there's a lot of that going around, and there are polls that say that the same kinds of polls show that, of scientists, show that even though fraud is very rare, this kind of hacking of the p-value, as they say, the significance value tends to be much more widespread and almost accepted as a way to get around these ridiculously high standards for apparent perfection that seem to be needed to be published these days. And some of I can't speak for any other field, but in my field of psychology, there is an initiative called the Open Science Framework, which you can Google, and they are looking at a variety of things policies to make things better. The most recent one, which I think is just brilliant, is for people to just voluntarily include in their papers a guarantee that this paper reports all the measures that we took that are relevant to the hypothesis and all the conditions we ran that are relevant to the hypothesis. We report the rule that we used to stop collecting data to avoid this technique of people just collecting data until they get their significant result. And even though someone who is a dedicated fraudster could certainly with impunity put that kind of statement in their paper and laugh all the way to the bank, nonetheless, for the average researcher who wants to do honest and research that has integrity, if that kind of statement became more of a norm, then I think integrity would be defined upward. And it's something that's in the power of individual researchers to do, with the hope that if more and more people do that, suddenly people will start to look at papers that don't have this statement and say, what's going on here? So I don't think this is something that is insuperable. I think it's something that we as scientists have to work towards and take initiative and take our responsibility for, or maybe it will be imposed from above with regulations, with onerous regulations that don't really fit with the way we would like to work.
I'd like to give a round of applause to our speakers today. Thank you.